Okay, can you hear me well? Yes. Okay. So with many thanks to our Solinus colleagues, meaning you did the sell for us, so our job should be very easy. What we'll do is we'll do a quick overview of ThinEdge, and then Ruben will do a great demo, and we'll end with a quick ecosystem presentation on the same. So let's get started. So ThinEdge 1.0 and the commercial version of ThinEdge called the Cumulocity IoT ThinEdge is out. Yeah, couple of months we had the first release, and so it is ready for production. You can put it in all your production environments. What is the difference between Cumulocity IoT ThinEdge, which is our commercial version, and ThinEdge IO is only the support. It is taken care as part of the Cumulocity support contract, but the way we deliver the versioning, those are exactly the same as our open source offering, ThinEdge IO. All the artifacts related to ThinEdge IO are available in the Cloudsmith repository, and the container images are also available at GitHub Container Registry. We have native Linux support, so various flavors of Linux operating system across multiple CPU architectures are supported. And also for Windows, you can always run the container-based ThinEdge. I wanted to also note that ThinEdge is in continuous delivery mode, so you don't need to wait for the releases. Every PR merge results in the artifacts getting merged inside the repositories, so you can get hold of them as soon as they are available. So I want to get started with the main challenges as to why we went about building this whole open source ecosystem around ThinEdge and doing the development for ThinEdge. As you know, cloud connections are complex. You have to take care of security, reliability, and various other constraints. You then have to provision and bootstrap your devices. You have to do, how do you do your firmware management? How do you install your applications? How do you manage the environments which are really resource constrained? And then you have high degree of customization needed. The whole firmware and the hardware landscape is really fragmented. So we have customers which have hundreds of thousands of devices across various device models, various hardware models, and have different topology and provisioning models. So you need to take care of all of them, and in many cases this results in multiple different forms of your connector. You are building different packages for the same connector, the same agent, which really gets complicated. And then you have these multi-cloud use cases where, on one side you want to, for example, manage your device management with Cumulocity, but you also want to push certain data to a blob store. All those use cases where multi-cloud is needed, you can always, you need to then therefore manage multiple cloud connections, etc. These really complicate the whole device enablement. There is this additional aspect, and this is a study from embedded market. With the increasing complexity of these IoT connectors, the cost on the development teams have been increasing. You can see that there has been more than 50% increase over the last 3-4 years. And there is not just cost in development, but also you have to continue to maintain these connectors, these agents. So, this really requires a different way, and that's pretty much ThinEdge's value proposition. So how does ThinEdge help with all the various problems which I highlighted? So in most IoT use cases, you have various devices. So all IoT use cases require, as I said, to connect to the cloud. You have PLCs, protocol gateways, control boards, which need to connect to the cloud. ThinEdge provides you a transparent way to connect, so you really don't need to, you can transparently install it and get your connection sorted with internally the certificate management and those aspects being automatically managed. You really don't need to bother about them. Additionally, as you connect to various clouds, you need to massage your data in the form or the format which are closer to the domain model of that cloud. right? And that also is, again, transparently taken care for you. So as you generate your data, as you pull or try to onboard your data through your device, you can push it to multiple clouds, and through the the IoT cloud agnostic architecture of ThinEdge, you get the benefits in a very simple and easy way. As you start your IoT journey and you start getting your devices onboarded, you start with bootstrapping your device. You want to provision the right firmware. You then have to install the custom logic through your software, various softwares which you want to install. And then it gets into the whole monitoring, managing, and debugging of those applications. We cover all these layers. So with ThinEdge and Cumulocity IoT Cloud, you get you get out-of-the-box support for complete device management, from firmware to configuration to software management, and then the whole life cycle aspects from monitoring to debugging. So you get the full stack, and you can do that both remotely and locally, so that you don't have to you really don't have to focus on the foundational layers which you need to build and which is need of every device, but rather you can focus on your IP, as we saw in the Solenis case with the excellent example of a focus on the IP rather than the standard foundation which is needed in every device case. So IT and OT convergence is required for your future enablement of IoT. And I want to touch base on 3 important elements there. The first one is the data, the CAN data which is available in your OT protocols. They need to be transformed and they need to be pushed so that IT computations can happen. And these ThinEdge provides a very pluggable mechanism so that you can have not just some of the default protocol connectors which we make available, but you can also pull in your own. You can develop your own protocol connectors and quickly onboard your telemetry data onto the cloud. Second, most of the production environments and your factory floors require near zero downtime. Therefore, near zero or near zero downtime become very important, and ThinEdge helps you in enabling that. So if you are doing, say, for example, a configuration change on your device, ThinEdge takes care of making sure that your downtimes are really, really low. In most cases, we would not need there doesn't need to be a reboot. And if there is a need for reboot of your because of a configuration application, then that would be taken automatically on only the component which needs to be rebooted and not the whole device reboot in that sense. And we can talk about it more. And then the resiliency aspect. The data as it is onboarding and is available on your device should not be lost. You want the right backup of your data or the storage of your persistence of your data on the device so that it is resilient enough before it is pushed to the cloud. All of this require really framework thinking on the device, and ThinEdge has been purpose-built to take care of all these aspects. As I talked about all the various needs from device management to the OT-IoT convergence, this is not a problem for just one device, but you might have a device hierarchy. You might have a microcontroller talking to a router, which is talking to your API gateway, or a combination of many of these topologies. And ThinEdge runs on all of your layers. So you basically get all the capabilities which I talked about in the last few slides across the full stack. Device hierarchy does not remain your problem. Also, the way your leaf devices or your child devices interact with your parent can differ, right? You can have HTTP protocol-based communication, or there might be authentication required for your child devices with the parent device. All that is managed, and you get a full end-to-end capability around that. ThinEdge is purpose-built to handle these device hierarchy use cases. So, just to summarize, ThinEdge advantages: it reduces your software development time and time to market, lowers the maintenance cost. You can develop your applications in any language. You know, your custom application on the device could be written in any language and can be provisioned very easily. You can have very simplified integration, has the full stack of device management capabilities, and all of that leverages high performance. ThinEdge is written in Rust as a programming language, so you get default memory guarantees, you have thread safety guarantees, and really high performance out of the box. So all of this helps you to not bother about all the foundational elements of your device, but rather just focus on your IP. I just want to end with some of the example use cases where ThinEdge is already deployed. So ThinEdge has become pretty much the de facto approach to get our device partners certifying their devices. It really helps them both with the amount of effort and the cost. You have these multi-cloud use cases where you want to do your device management with Cumulocity, but you have certain sets of data which you want to push, for example, to an AWS blob store. You can do that directly from the device, and you don't need to go from one cloud to another cloud. And then you have these data security cases where most of your solution resides in an on-prem campus network environment. You can have, with the Cumulocity IoT Edge and a combination of ThinEdge, you can solve all the same problems inside your local campus network without ever needing to touch the cloud. And all of this already has been, so you work in a completely air-gapped environment in that model. At the point where you want to push your data from local environment, local edge to the cloud, that also is totally possible. And then, as I highlighted, you have the device hierarchy case where some of our customers are using it to handle their full device hierarchy, with analytics workload being provisioned not just on the gateway device, but the whole device hierarchy stack. And with this, I hand over to Ruben Yu for the demo.
Yeah, thanks, Roshan. Just mic check. Hello? OK, thanks. So my name's Ruben Miller. I'm the product owner for ThinEdge. And I'm going to work through a bit of a demo, and it's going to be live because I like doing things live. I'm just going to take my chance. So I'm going to be going through the whole kind of workflow of a device. So going from the initial creation of the device, bootstrapping, they'll have some standard features out of the box. Then, what do you do when you want to add some new functionality, like an OPC UA server, or client? Connect that, maybe do some diagnostics, and then also provide some configuration and kind of management. So just to show that I'm not lying, at the moment we have 2 devices there. Those are my backup devices. So the devices I'm going to create now are going to be live. So I'm just going to use, so for these examples, I'm going to use the containerized version of ThinEdge. This is exactly the same version. It's just due to networking of the hotel, it was a little bit tricky to then show the bootstrapping because the clients are isolated. So I'm just going to spin up a container, and I'm going to create a demo live one. Just confirm. And so this is spinning up a container. So this is actually a single process Dockerized version. So it's actually multiple containers working together to provide the functionality of ThinEdge. As you can see, as I was talking, I'm done. So this is really, really convenient for development scenarios. You can kind of test your whole things, like your whole solution on your laptop. You don't need any kind of physical devices. So this represents the initial construct that I've delivered a device, which has like a base image, which has some certain software installed. So here I have a lot of APK packages, because I'm using Alpine-based Linux. But at the moment, it maybe doesn't have everything that I want for my device. So after you do the initial bootstrapping of your device, you might want to add functionality to it. So using the great software management plugin kind of functionality, you can actually develop your own kind of software management plugins that do whatever you deem a package is. You can install it, uninstall it, and also then get information about it. So for this example, I'm going to use the OPC UA device gateway. which is a gateway. So it's a Java-based client that Cumulocity then wrote. And I'm just going to deploy that. And so by just doing this kind of like at runtime, you can then extend the functionality of your device. And so for specific customers, when they need this, you can basically provide a easy to deliver one-click installation so they can get the functionality that they want for their devices. And if I look at the events, we can see that the OPC UA gateway has already started. So let me just refresh that so I can see it in the child device list. And it's already registered here. And if I go to the OPC UA gateway, I could then configure whatever OPC UA server connection that I want to establish. And then you can already then pump data from an OPC UA server, then back to Cumulocity very conveniently. So then once you to deploy your applications, so if you have a configuration step, you can then integrate the configuration management from ThinEdge, by either the classic get set kind of stuff, or you can also deliver configuration via software. There's nothing stopping you doing that. If you want to kind of more manage all of your configuration via software packages, because they're more well-defined versions, that's also free to use. But then after the configuration, so we've installed the application, we've configured it, so everything's good. Now you kind of want to monitor it, like, is everything working as expected? So that's where the services is great, because you can get a representation, let me make that a bit bigger, what's actually running on the device, slightly small. So you can then represent that we have like the ThinEdge components running there, the bridge is up, happy, good. And then we have like a few custom components, so the TEDGE container monitor, which is then providing the functionality of the insight, what containers are running, and is everything okay? And this is where like a lot of the extension aspects from ThinEdge then play nicely with the extensibility of Cumulocity and the extension kind of concept, that you can really build these rich elements, because the services is an inbuilt functionality. But when I go down to here, I can actually see that so let me go down the OPC UA gateway. So that's actually the container running the OPC UA gateway. I can click on it, and this is a custom, freely available UI plugin for the container management. So it can also go into a bit more details that, yes, my container is running. I can see, the entry point used and what image it is. So you can get this detailed information about what is actually running on your device, which is then helpful for any kind of troubleshooting scenarios when something goes wrong. And again, with measurements, you can kind of monitor your container runtime to see, how many resources are used on your device. So for the, so that's like kind of runtime. And then the next question is, what happens when something really goes wrong? How do you do this kind of advanced troubleshooting? So for that, I'm just going to switch to another demo. And again, I'm going to spin it up. I think last time I did 60 seconds. I think I can do better. Was it demo 02 live? So this is spinning up another instance. So you can host multiple instances also on your laptop. That's fine. And you can actually all do this on a real device as well. So if you have a container engine running, that's also fine. And that is up and running. Live device 2. And for this instance, it's slightly different. So it actually has pre-configured child devices, because maybe I want to communicate that it can connect to how do like different child devices then appear in ThinEdge context, how they register themselves, etc. But I wanted to focus more on the remote access kind of element. So if something really goes wrong and going, okay, maybe you're having a tough problem with your deployed application, you want to kind of go into the nitty-gritty details of what's happening on the device. That's where you can use the remote access. And here I'm just going to use the web SSH. So you can configure this. You can change the password. This is just a demo. So Google, Chrome's going to warn me about it's a terrible password. But here, so using the web SSH, which is really convenient, especially if you only have access to like a web browser, you can then get on your device and then do your, get rid of caps, sudo, docker ps, And then you can kind of see what's happening. Oh, this container is not running. You can do a Docker inspect or whatever. So it's really flexible that you can kind of cover all the bases. So the installation, configuration, the troubleshooting, the logging, everything's kind of out of the box, but you can also extend it when the out-of-box functionality doesn't really hit the spot for you, or you need to then focus on your IP, then it makes it easy to write these kind of small things. And just as an additional demo, I'm going to try something even fancier. So I'm just going to install Python just manually because I just need something really, really quick. And because you can actually use this remote access to do even fancier stuff, like giving access to a local HTTP endpoint or like service. So the screen's a little bit big. I'm assuming it finished. Yes. So here, I'm just going to start to represent a web app. Start a web server on the etc, oops, if I typo, etc folder. In Cumulocity, with, again, an extension or microservice, it's all available. We can actually extend, so make this endpoint actually accessible. Here I'm just giving the port number, 8080. So it's very rudimentary version, but it's just to highlight the point. So here I've configured a, let me make it bigger so you can actually see that. So this is accessing the local web server that I just spawned up via remote SSH anyway, to give access, and you can kind of click through and then browse through that. So obviously in real life, this would be like a actual web page that you can have locally, but that is really, really cool for, especially if you're coming from control systems, where you might have a local UI and you kind of want access to that from the cloud. Fantastic. So then going back to the slides, so everything I demoed here, you can do it yourself as well. So you can spin it up in 60 seconds. That's part of like the all-inclusive TED demo container. So I'd really encourage, it's a good kind of stepping stone to get used to ThinEdge. What can it do? And we kind of put everything in the kitchen sink in that. And it's really meant to represent a device. So it has systemd and everything in it. So you can also test your solutions in this kind of environment. But we also have other variants that is more kind of like container friendly. So, one process per container. But basically everything I've shown today in the demo is really highlighted by our kind of architecture and extensibility. So I showed a kind of cross-section of stuff that was supported out of the box, but also like the container management, that was an extension or a plugin. So it's really easy to kind of extend to your own kind of modules. And all of the modules that we have available, we make them also available from the community repository, so you can also download it. We're also open to people also publishing that to as well, to that repository as well. Just reach out to us and we can kind of get publishing access to it. But it's really extensible, and also what I didn't show, ThinEdge can't run on microcontrollers, or at least not at the moment. It would be nice if we could, but at the moment we can't. But you can still, it makes your development a lot easier. So we have two examples. We have a MicroPython example of a ThinEdge agent running on a microcontroller, and also an ESP32 free RTOS version, which we wrote together in 1 week. And that code's all available. So not only like if you have a microcontroller but still have a ThinEdge gateway in the local network, it still makes your development life easier. Because the ThinEdge interface, you're just looking at local communication and nothing else. So with the developer community, so we have a list of all the plugins that we have available on our website. So you can check that out and a bit of exploring. And if we're missing something or you want us to add it to our website, just reach out to us, create a GitHub ticket, or reach us on Discord. But we also have a lot of like engagements in the different kind of various communities. So we're in the OSS community. So we've done a few talks there. We were at the Embedded conference this year and won Best in Show. which was a very nice kind of validation for us. But again, with all the plugins, what a big element from it is how do you ensure the quality of the plugins? So usually if you have like this well-defined kind of box of this plugin, which is input-output, fairly simple, but you still want to validate, does it work with the latest ThinEdge version? Or does your new functionality changes in that plugin break something? So what we actually have in a lot of those community repositories is actually system tests and a framework behind that. So in Robot Framework, to facilitate and uses the same ThinEdge demo container, packs the application in it, and then tests it in this end-to-end kind of system test. So it's not just about developing the little functionality you want to deliver, it's about the whole kind of package, end to end. So that's really important for us to also like communicate the quality of different plugins that we have in the community. So if you have more questions, I'm also available after this talk. I can talk forever. But then I'll hand over to Christian.
Yeah, thanks, Ruben. So I have the pleasure of having the last slide, I guess. And yeah, my job is to increase the adoption of ThinEdge, so people actually have access to it the easiest way. So I'm in exchange with all the hardware partners that have various types of integrations with Cumulocity IoT, and you guys actually make my life a lot easier because I don't have to nitty-gritty explain the APIs anymore when people use ThinEdge, and we have a lot of partners already adjusting it and using it in their product. Phoenix Contact, Kunbus, Advantex using it, Surfwave, Internet Networks, Oasis, and a number of entire list investigating it currently. So there is going to be some more traction assumed to be happening for the future. And I mean, our device partners are also, as I feel, a little bit scattered around the maturity curve. So it fits better and worse with some partners. For example, Phoenix Contact is not an ideal fit because they have a separate real-time operating system and a separate operating system where the user can actually be active and not interfere with the real-time system. So there's a perfect match. Whereas for other customers and device partners, it would be embedded into their firmware deeply. So it's, let's say, a longer journey to achieve that, especially considering the high, let's say, the initial investment is a lot lower, let's say, moving to ThinEdge initially. This is why it's a very easy job to convince new partners to using it. For existing partners, it's a bit more work and requires exchange with customers, having that match, and convincing to switch to a new superior technology that is maintained and in the long run going to be hopefully predominant. So whenever you have a partner or a device partner that's not yet using it, I'm happy to exchange with you and try to accelerate also their development process. Okay, yeah.
Thank you very much.
I guess that's it.
Any questions?
Yeah.
If we have time.
Thank you very much. Excellent, excellent presentation and demo. Any questions?